Welcome, my viewers. This is 2026 WAEC Mathematics Theory, question number 7, A and B, the complete solution. Let us solve the question. On a certain day, Mabel rode her bicycle for 45 minutes and then walked for 1 hour, covering a total distance of 10.4 kilometers. Now, the average cycling speed is 3 times the walking speed. And the question has asked in the I section that we should find correct to two significant figures, the walking speed and the II, if Mabel increases the average cycling speed by 20%, but maintains the walking speed for 1 hour, find in minutes the new cycling time. Okay, let's begin. Now, by interpreting this question, first and foremost, let us write down the walking speed. The walking speed is given to us as W, okay? We represent this as W, okay? Walking speed will now be W kilometers per hour, okay? Because they said it is walking speed. And the walking time is given to us as 1 hour, 1 hour. Okay, let's go for cycling. For cycling speed, which also is told from the information given to us. So cycling speed is said to be 3 times the walking speed. So I am going to write 3 multiplied by W because W represents the walking speed. And this is also in kilometers per hour. Then what is the cycling time? Cycling time is given to us as 45 minutes. So cycling time is now 45 minutes. But you know what? We are going to convert it to hours. This is the same thing as 45 divided by 60. And that will give us 0.75 hour. Okay, so we work with hours because speed is involved. And already the working time is in hours. All right. Now, let's now go proper into the solution. We are asked to find the walking speed, which is W kilometers per hour, meaning that is unknown. All right, what do we do? Let us see that the total distance is given to us. Total distance is given to us as 10.4 kilometers. But what is this total distance? Total distance is the distance covered walking and the distance covered during cycling. So the two put together will give us the total distance covered. But then how do we find the distance for each of them? From the speed formula, speed is given by distance over time. By cross multiplication, we can find that distance now is equal to speed multiplied by time. So let's find for walking. All right. This means that distance covered walking will now be equal to the speed for walking was W kilometers per hour multiplied by the time for walking was 1 hour. Okay. So this is going to give us W. Okay. Remember, this is distance walking. So WKM. That is the distance walking. All right. Now, also, what is the distance covered cycling? Distance covered cycling is going to be still the same speed multiplied by time. So this is now going to be for us. Speed for cycling was 3W kilometers per hour multiplied by the time. And the time we converted it to hours. It gave us 0.75 hours. So we have to multiply the two together. And that means 0.75 multiplied by 3 will give me 2.25. All right. So I am now going to get this cycling time as the distance covered cycling as what do I have here? 2.25 W. All right. What did I do? I did 3W multiplied by 0.75. Now, all these things, what does it mean to me? It means that the addition of the distance covered walking plus the distance covered cycling must be equal to what I was given as 10.4 kilometers. Yeah, this equation will help us to find solution to question I, where we are asked to find the walking speed. All right. So therefore, remember W represents the walking speed. Therefore, what I will do now, I am now going to write this equation that W plus 2.25W should be equal to 10.4. Beautiful. All right, because the total distance covered was 10.4. Now, distance covered walking is W, and the distance covered cycling is 2.25 W. So if I add the two, I am going to get 3.25 W is equal to 10.4, meaning that W alone is going to be 10.4 divided by 3.25. Let's work it out. All right, 10.4 divided by 3.25. That is going to give me exactly 3.2. What does this mean? It therefore means that the walking speed that the question has asked in question A, since we say that W represents, look at what we have above here, we say that W, that is walking speed, look at where I set it here on the top, is equal to W kilometers per hour. So what I got now is the exact value of W. So I will now write 3.2 kilometers per hour. This is the solution and the correct answer for question number AI. All right. Moving forward from question AII, if Mabel increases the average cycling speed by 20%, okay, but maintains the walking speed for 1 hour, find in minutes, okay, the new cycling time. That is, the new cycling time now means when the speed is increased by 20%. When the cycling speed is increased by 20%, what will now be the new cycling time? So the time will no longer be 0.75 hours or the 45 minutes as earlier given. So it's going to also increase because the speed has also increased. All right, or rather it is going to change. Let's use that language because the cycling speed has changed. Now moving to that, to question II. We now have it that AII, the new cycling time. But I can see, since the total distance is 10.4, I can simply write that 10.4 minus 3.2 will give me now the exact cycling distance, because that one is not yet known. So therefore 10.4 minus 3.2, okay, will now give me 7.2 kilometers. What does this mean? This is now the cycling distance. Okay? Cycling distance. That is what it represents. Therefore, I want to find the increase. Now, what happened on the increase? We want to increase 20% the cycling time, the cycling speed. But what was the cycling speed earlier? It was 3W. So I'm going to now do cycling speed. Okay, cycling speed now will be 3W, which is now 3 multiplied by the value of W, which is 3.2. Beautiful. Yeah, it is going well. It is going well. So I'm not yet finding 20%. I want to first know the cycling speed because it was given before as 3W, and now that we have gotten the actual value of W, so we have to use it to find the exact cycling speed. Now, what I will write is 3 multiplied by 3.2, and that is going to give me 9.6. 9.6 speed is what it is, kilometers per hour. So this is now the exact cycling speed in the initial journey. I will now increase it by 20%. You get me? Therefore, 20% of 9.6 will now be 20 all over 100 multiplied by 9.6. Let's work it out. Okay, this is 9.6. So we work it out. 9.6 multiplied by 20, then divided by 100 is going to give me 1.92. This is now equal to 1.92. What does this mean? We can now say that the new cycling speed will now be the original cycling speed, which is 9.6, plus what? The extra increase, which is 1.92. Okay, so I add it to plus 9.6. That will now give me equal to 11.52. What does it represent? Speed. So I write kilometers per hour. All right, beautiful. Now, remember, the question has asked us to find the new cycling time. I'll still go back to speed. Note again that speed is distance over time. So therefore, to know time, I will simply say time is equal to distance all over speed. Therefore, new cycling time will now be the distance, okay? And that distance for cycling, we got it above. Distance for cycling distance, okay, it was 7.2. Look at it here. Cycling distance was 7.2. So that is what I'm going to use now, okay? So cycling distance remains 7.2, but the cycling speed has changed from 9.6 to 11.52. 11.52. So this will give us exactly the new cycling time. So I divide 7.2 divided by 11.52. So this is now going to give me 0.625 hours, okay? Because everything we have here is in hours. But the question has said that the answer should be in minutes. Back to it. Look at it here. You say, if Mabel increases the average speed by the average cycling speed by 20%, but maintains the walking speed for 1 hour now, find in minutes, this is my interest area, find in minutes the new cycling time, okay? That is what we are working for. Therefore, I am going to convert the time I got in hours to minutes, and that becomes the final solution to that question II, okay? So therefore, to do that, I write, just multiply by 60. Therefore, in minutes, it will now be 0.625 multiplied by 60. So this value will multiply by 60, okay? And that is going to give me 37.5 minutes. Final answer for question number 7A. All right, we move forward to question number B, okay? In number 7B, we are given a line L passing through a point K, and the value of K is given as, the coordinate of K is -3,5, okay? So there is a line L passing through this point K, the coordinate K, and it's parallel to the equation 3x minus 2y plus 5 equal to 0. What are we asked to find? The equation of L. So we are going to find the equation of L. So I scroll down. When the coordinate is -3,5, when the coordinate is -3,5, what will I do? I want to change the color of my pen. So 7B, number 7B, when the coordinate K is -3,5, and the equation given to me is Let's go up and get it again. 3x minus 2y plus 5 equal to 0. 3x minus 2y plus 5 equal to 0. All right. That we should find the equation of L. All right. Since L is passing through this point, see what we will do. The equation of a line or two lines are parallel when their gradients are equal. If the gradient of the first line is equal to gradient of the second line, then they are meant to be parallel. Okay, therefore, going by this fact, we are now going to first find the gradient of this equation given to us. And that means I will use this formula, y equal to mx plus c. Okay, this is the equation of a straight line in gradient form. Equation of a straight line in gradient form, where m represents the gradient. So I want to now translate this equation in this form. That means I will write minus 2y is equal to minus 3x, then minus 5. What has happened is that I took 3x and the plus 5 from the left-hand side to the right-hand side. And if I work it out now, it is now going to give me that y will now be equal to minus 3x over minus 2, then minus 5 over minus 2, making that equation to look like this: y equal to 3 over 2x plus 5, making the gradient m1 equal to 3 over 2. But remember, when the gradient of the first equation is equal to the gradient of the second equation, we now conclude that the two equations are parallel. By this, it means therefore that the second equation, that m2 also must be equal to 3 over 2 for them to be parallel. By this now, I can now go ahead and define the equation of L. So, equation of L will now be y minus y1 is equal to m into x minus x1. This is formula to form an equation when there is 1 point given and gradient is known. You understand? Therefore, and the point given to me is minus 3, 5. I want to be sure that I'm using the accurate value in the question paper. Okay, minus 3, 5 is accurate. All right, so we go ahead. Now, I will write y minus the value of y. Hold on. Okay, the value of y here is 5. So y minus 5 is equal to the value of the gradient, which is equal to the gradient of the m1. So which is now 3 over 2. Then into x minus x1 is minus 3. So minus minus we change to plus. Moving forward, I will have it as y minus 5, okay, multiplied by 2, okay, will now be equal to 3x plus 9. That is, I open the bracket. I use 3 to multiply the bracket here. It gave me 3x plus 9. And this 2 is cross multiplied to the left-hand side, and it will be multiplying this. So opening the bracket, I will get 2y minus 10 is equal to 3x minus 9. I can rearrange it and write it as 2y, okay, minus 3x minus 10. This is plus 9 here. Then minus 9 is equal to 0. So finally, if you like, this equation is already formed. We write it as 2y minus 3x, then minus 19 is equal to 0. Final answer. This is the equation of L. This is the equation of line L. Okay, so at this, we come to the end of this question number 7 in the WAEC theory question exams 2026. Please, I beg you, kindly subscribe to my channel for more WAEC past questions exams. I am going to solve all the questions that were asked in theory in WAEC 2026, as well as all the past objective questions in 2026, and many more past questions, WAEC, NECO, JAMB from other years. Thank you and God bless.